Hi, welcome to this overview of disaster recovery options for the Spectrum Protect server. What I'm going to go over is what can cause a disaster, what on the Spectrum Protect server needs protecting from such a disaster, and then a look at some of the different types of protection and recovery that are available for the Spectrum Protect server. And as I go through this presentation and say server, I'm referring to the Spectrum Protect server itself, where the data is being protected at. I'm not talking about the production machines that we are protecting. When we look at why disaster recovery is so important, there's all different types of failures that can impact your Spectrum Protect server. It might be a power outage or some type of earthquake, flood, tornado, fire at your primary location where your Spectrum Protect server resides. It might be a machine failure on the hardware that your Spectrum Protect server is running. Maybe a motherboard goes out, maybe a power supply problem. There could be some sort of local resource failure like a disk drive or fiber channel adapter or network adapter. Or it might be something like a virus or ransomware that infects the operating system that the Spectrum Protect server is running on. In addition, there are regulatory requirements that mandate a disaster recovery plan be in place. This might be government requirements or some type of industry requirements. The bottom line when it comes to disaster recovery is if you do have a site-wide disaster, until your Spectrum Protect server is up and running, you cannot be restoring the files and data to your production machines. When we look at the Spectrum Protect server, there's specific pieces that have got to be protected no matter what type of disaster recovery scenario you implement. The first one is going to be our database and logs. With Spectrum Protect version 6 and above, these are DB2 databases and their associated logs. In these databases, the Spectrum Protect server stores all the meta information about what's being backed up, who owns it, how long to keep it, where it resides, passwords for the administrators and the clients, and all types of other meta information. The actual data that we're protecting resides out in the storage pools. And these storage pools might be disk, they might be tape, they might be VTL, they might be cloud, and they're probably a combination of a lot of different pieces. For the databases, customers will use the backup database command that's part of the Spectrum Protect server. And this is usually creating a database backup and making sure that all the logs are properly in sync when the backup occurs. And this usually is out to either a tape or to a SAN attached device or to a device that then replicates it offsite. For the storage pools, we have the built-in capability to do the copy storage pool, where you get a second copy of your legacy storage pools. For the container storage pools, for directory, we can create a tape copy. But for most storage pools, you will have a copy storage pool, and that copy will either be off to tape or off to some type of SAN attached device. So those are the two pieces we have to have in order to restore the Spectrum Protect server: the meta information and the actual data that we're protecting. Now, some pieces make a recovery of an entire Spectrum Protect server easier. These are things like your server configuration files, your dev config files, your option files. And built into Spectrum Protect, we actually have a tool that helps you gather all this information. It's called our Disaster Recovery Manager. It's very simple to set up, and it will create on a nightly basis a disaster recovery plan. In addition, it can track offsite volumes if you are taking those tape volumes offsite. So do check out the Disaster Recovery Manager piece if you don't already have that up and running, because it will create and consolidate a lot of the information that's going to make the recovery of your Spectrum Protect server easier if you lose your entire Spectrum Protect server. When we talk about a disaster recovery solution for the Spectrum Protect server, some of the things you got to consider are: where would you do your disaster recovery? Will it be at a different data center? Will it be geographically different, as in just across the campus? Or is it across the city? Or is it across the country? Or perhaps even in a different country? Next is the recovery time objective. How fast do you have to be able to start doing those restores to your production machines? The next piece is your recovery point objective. Up until what piece of your backed up data do I need to be able to restore? Was that last night's backup, last week's backup? Or was that the backup that just occurred 2 minutes ago that I need to be able to restore from? Finally, how much money are you able to spend on a disaster recovery plan? So all of these pieces will play into the disaster recovery solution you choose for your Spectrum Protect server. In the industry, a lot of people talk about the 7 tiers of disaster recovery. So I did put a chart out there that kind of maps the Spectrum Protect servers with the different tiers. In this presentation, I'm going to be focusing on Tier 1, Tier 2, and Tier 3, because these are features that are built into the Spectrum Protect server, whether they're database backups or HADR. The other tiers are very reliant on hardware solutions, so I won't cover that in this presentation. In addition to the tiers of disaster recovery, there's also talk about what is the status of your disaster recovery server. Is it a cold server? Is it a warm standby? Or is it a hot standby? Cold meaning that that disaster recovery site does not have a functioning Spectrum Protect server installed and ready to go. In order to do a recovery, we'd have to start from scratch to rebuild that Spectrum Protect server, restore the database, and get it access to the copy storage pools. Now the warm is somewhere in between the cold and hot, and I'll show you some examples of that here shortly. And hot means that the Spectrum Protect server is up and running, and we can fail instantaneously over to that Spectrum Protect disaster recovery server. First piece is the most simplistic, where we will utilize the backup database command inside of the Spectrum Protect server and the copy storage pools out to tape. So in a normal day, you would create a copy of your storage pools out to tape, and that is an incremental copy. You would then do a database backup out to tape, check both of the database backups and the daily copies out of the library, hand them over to a courier who would put them in a truck and send them to a vault. And those stay in the vault unless we need to reclaim the space on them and reuse those tapes. In a disaster, we would generate a list of the volumes that we need from the vault. We would bring those back onto site, rebuild our Spectrum Protect server from scratch, and then start restoring the data out to your production machines. So as you can see, the recovery time objective is fairly long because you've got to acquire, provision a Spectrum Protect server, you've got to restore the database, and then get it access to the copy storage pools. The recovery point is based on where in the backup cycle and offloading cycle you're at. Did the database backup just occur? Is the database backup been taken off site? All of this impacts what your recovery point is going to be. The benefits are that you don't need any bandwidth between your primary Spectrum Protect server and the disaster recovery site. And the cost is fairly low when it comes to terabytes of storage because you're just doing tape storage. However, this is a little bit more human intensive because you've got to have people checking the volumes out of the library, couriering them off site, storing them in the vault, and so forth. Tier 2 warm. In this case, we're using the same procedures that we just covered where we do the Spectrum Protect copy storage pool and the Spectrum Protect database backup out to tape, and we query that information off site. But in this case, when it gets off site, we put it into another library. And now if there's a failure, we can simply attach that library to a disaster recovery server, rebuild that server, audit the library so it knows where all the volumes are, and then we can start the restore. So it is a little bit faster in the fact that you don't have to pull the volumes out of a vault. They're already in a library and ready to be utilized, but you still have to restore that Spectrum Protect database and audit the library. This is another take on that same scenario, but in this case, we do the storage pool copy out to tape, we do the database backup out to tape, but when that tape reaches the DR site, we actually do a restore of the Spectrum Protect database regardless of if a disaster has occurred or not. Each day, we're restoring the Spectrum Protect database and priming the DR Spectrum Protect server to be ready in case there's a disaster. If there is a disaster, all we have to do is have the Spectrum Protect client start accessing this DR site instead of the primary site, which means you probably have to update the option files with the new IP address of the DR site. The recovery point objective depends on where in the database backup cycle you are when the failure occurs. The cost of this solution would be slightly higher because you do have to do that restore database on a daily basis, and you do have to have that hardware already pre-allocated as a Spectrum Protect DR server. The solutions we just talked about utilize the built-in Spectrum Protect database backup capability. But many customers have hardware out there that can actually replicate the Spectrum Protect database from one location to another. In these cases, we have to include in the consistency group both the instant directory, all of the database directories, the active directory, and the archive directory for the logs. All of those have to be replicated over to the secondary location. With this tier 3, for the storage pools, we are going to utilize either a simultaneous storage pool write utilizing SAN attached storage, or we're going to do a copy storage pool to a SAN attached storage pool. Either way, the storage pool is taken offsite because it's being copied to a second device that is attached to the storage area network. To get the database offsite, we could either do database and log, have it mirrored over to another site, or we could have the database backup done to a SAN attached storage, and then when we would restore that database to a secondary Spectrum Protect server. And in addition, we could have a Spectrum Protect server at a secondary location with the software already installed, but it's not running. The Spectrum Protect database is sent over on a daily basis to that server. And so then if a failure happened, all you'd have to do is bring up your DR server, point it to the SAN attached copy of your storage pools. You'd probably want to run an audit just to make sure it knows where everything's at in that SAN attached copy. And then you could start your restore. In this page, we are basically using a storage area network instead of a courier to take the tapes and the copies of the storage pool and database offsite. The recovery time objective is going to be minutes to hours depending on how you replicate across your database. The recovery point objective is going to be based on where in the backup cycle you are when the disaster strikes. The big thing here for the challenges is that your database and logs have to be correctly copied to maintain consistency if you are doing some type of SAN attached copy. If you're just doing a database backup, then you just want to make sure that whole database backup, and if it's an incremental backup, you would also want to make sure all of those versions are available at the DR site. Slide 12 now starts to introduce the ability for some hardware to do its own replication. We are no longer using the copy storage pool capability. Instead, we have the Spectrum Protect database backup to a device prior to the device replication cycle. The Spectrum Protect database backup occurs and it's written out to the local smart device. Then we have the device replicate both the backup of the database and all of the storage pool data off to a second location. Now, when it comes to doing a DR scenario, we would rebuild the Spectrum Protect server at the remote location and restore the database from that backup we did. We would make sure it could see the copy of the storage pool. We might have to run an audit to make sure that it reconciles the server database with the storage pool volumes. And at that point, you could restore the information. So your recovery time objective is still hours because you've got to restore your Spectrum Protect database. And your recovery point objective depends on when the backup cycle of that database backup was replicated across. The nice thing is that this is faster and there's less human interaction than the courier method. On page 13, we take this hardware replication a step further by utilizing the built-in DB2 high availability disaster recovery, HADR, that comes with Spectrum Protect. First of all, you're going to have the storage pools replicate continuously from one device to another. You'll then perform the database replication utilizing the DB2 HDR, and that also will happen continuously. If there is a disaster, then you'll stop your primary server, and so that no longer replication is occurring. Then on the DR site, you'll start the Spectrum Protect server, Make sure it sees the replicated database and the replicated copies of your storage pool. You'll probably want to run an audit to make sure the database and the volumes are consistent. The benefits of this is it's fast. It takes advantage of the built-in DB2 HADR. Your DR site is still going to be a warm site. It's not up and running until you have broken the replication and started the server at the DR site. Now, some of the challenge here is that at the DR site, your Spectrum Protect server and the disks must pre-exist. You do have to set up HADR, and the HADR itself does not allow a suspend and resume option. So if you are doing any type of testing on this scenario, it will require a snapshot of the server database to prevent having to reinitialize the HADR from scratch. Your recovery time objective is fairly short. All you have to do is stop the replication and start the disaster recovery Spectrum Protect server. And your recovery point objective is going to be as current as the device storage and database replication was. I do have a link here at the bottom that talks in more detail about HADR in conjunction with the Spectrum Protect server. And the final scenario I'm going to cover is utilizing node replication. Node replication is built into the Spectrum Protect server. It does not utilize DB2 backups or copy storage pools or any of that technology. In order to set up node replication, you do have to have two Spectrum Protect servers. The first server is obviously your production Spectrum Protect server, your primary server. Your second server could either be another Spectrum Protect server that's being used to protect other machines, or it could just be a Spectrum Protect server that's dedicated to disaster recovery. When you set up node replication, you can get granular about what you want to replicate to the DR site. Is it going to be just specific nodes or file spaces or data types? Or is it going to be all of the information in your Spectrum Protect server? And when we do the node replication, we are doing incremental replication. So it's only replicating the new data over to the DR site. Everything can be scheduled to run so that after your backup's complete, we can kick off the replication. The client data on the DR site is available immediately after node replication finishes. And if you are using our new containers, you can optimize this even more with the directory container by using the protect storage pool command, which can be run while your actual backups are occurring. And it expedites replication by just replicating across the extents of the data that we're protecting. And then after the protect storage pool commands finish, you then run node replication to get the meta information across. Now, some of the challenges with Spectrum Protect node replication is you do have to have a network that can accommodate the data transfer. And both your primary and your target server do need to be sized to accommodate the extra data and CPU that's going to be generated when utilizing node replication. We still do honor the deduplication that occurs, for instance, in the container storage pools. So that'll be less information being sent across the network. It is, once again, incremental, so we're only replicating across the new data. It does not utilize any type of hardware replications. The recovery time objective is immediate. The recovery point objective is based upon when the last backup occurred and where in the node replication cycle you are. So if you've set up your clients to have automatic client failover, if the clients cannot reach the primary server, they will automatically switch over to the secondary server for restores. This solution only supports restoring the data from the secondary site. It does not allow you to start doing backups to the secondary site. I still recommend strongly that you are doing database backups so that if something did happen on your primary server, you still do have your database backups available. I've only covered a few of the different scenarios you can utilize for disaster recovery. As you can imagine, there's many different ways to set up DR and many different combinations of this type of technology you can utilize. In this presentation, I did not cover clustering or snapshots. I did leave them in this chart here so you can see if you have a power supply problem or a disk failure or a fire in your IT center or flooding. The X's in here show which of the DR scenarios will cover that type of disaster. In the chart below, I do talk about what is required in order to do a recovery on each of these scenarios. Do I have to restore my Spectrum Protect database? Do I have to apply logs and do other types of crash recovery? Do I have to reconcile the storage? Do I have to update my primary pools to unavailable? And so all of this shows in this chart here. The biggest takeaway from this presentation is please test your DR solution. No matter which solution you choose, test it, and test it again. This DR strategy is going to be of no value if the process or procedures that you've put into place are incorrect or incomplete. So by doing a DR test, you'll be able to rest assured that if something happens to your IT center, not only would you be able to restore your Spectrum Protect server, but also all of your production servers that Spectrum Protect is protecting. Thank you very much for your time.